Good morning to all. Myself Nijeesha, Assistant Professor of Computer Science Department, Emmanuel RSHG College of Engineering. Now I am going to teach about software development life cycle in data and information security subject. First, what is software development life cycle? That is SDLC. It is a systematic process used to plan, develop, test, deploy and maintain the software. It provides a structured approach for producing software that meets user requirements while maintaining quality, security and reliability. SDLC is a step-by-step process used to develop software from an initial idea to a working and maintained system, and it provides a clear and organized framework for managing development phases, and it helps in early detection of defects, reducing overall cost and time. It ensures high quality software delivery that meets user expectations. Next is why information security is important in SDLC. In information security protect three types, that is confidentiality, integrity and availability. Confidentiality means it prevents unauthorized access, and integrity means prevents unauthorized modification and don't change anything in the data. And availability means it ensures system and data are accessible. If available time, the data are availability. The security must be considered throughout the SDLC because vulnerabilities can be introduced at any stage. It provides a clear and organized development framework. And this information security improves planning, cost control and project management. It ensures better quality through defined testing phases, and it helps deliver software that meets user and business needs. The characteristic of SDLC: sequential process, its clearly defined phases, extensive documentation, limited flexibility. Requirements are usually established at the beginning. And this next are the stages of software development life cycle. There are six stages in software development life cycle. That one by one. First is planning, second is defining, next designing, building, testing and deployment. These are the step by step process of software development life cycle, and these are the stages or phases. The first one, stage 1, planning and feasibility analysis. In planning stage, the stage determines whether the project is technically or financially and operationally feasible. Here the activities are feasible analysis, cost estimation, scheduling and resource planning. The output is project plan, that is feasibility report. Key roles are project managers, senior engineers and stakeholders. These are the picture of stage 1, planning and requirement analysis. First, in planning goes to define project scope, set objectives and goals and resource planning. Next stage is a requirement specification, that is SRS. In the stage, detailed functional and non-functional requirements are documented clearly and approved by stakeholders. Here the activities are requirement gathering, validation and documentation. The output is SRS, that means software requirement specification. Here the key roles are business analysis and product owners. These are the stage 2 diagrams. Defining goes to functional requirement, technical requirement and requirement reviews and finally approved. Stage 3 is system design. In this stage, the approved requirements are transformed into a technical blueprint for implementation. High level design and low level design. These are two designs of the system design. In high level designs, it defines system architecture or technology stack, database design and major modules. In low level design, it specifies component logic, APIs, data structures and workflows. The output is DDS, that is design document specification. Here this is the stage 3 diagram of designing architecture. First design goes to low level design and high level design. The stage 4 is coding. Coding means development. Developers build the software based on the approved design, Activities are coding, code reviews, unit testing, version control management. Here the used tools are IDEs, version control system, debuggers. Output is source code, executable application. Key roles are front end, back end and full stack developers. In stage 4 diagram, this is developing product. Development is coding standard, scalable code, version control, finally the review of the code. In stage 5, this is testing. In testing stage, here many types of testings are there. This testing ensures the software meet requirements and is free from defect before release. Types of testing are unit testing, integration testing and system testing. In unit testing, it verifies individual components. Integration testing, it ensures modules work together. In system testing, validate the complete system. UAT means user acceptance testing. Finally, it confirms the business requirements or not. Output is test cases, defect reports and quality matrices. In the stage 5, product testing and integration diagram, the system testing goes to manual testing, finally automated testing. Stage 6 is final stage, deployment. Deployment, the tested software is released to users. Final stage, and activities are production setup, deployment, smoke testing. Modern approach, continuous integration and continuous deployment, that is CI is continuous integration, CD continuous deployment, pipelines for faster and reliable releases. The output is live application. Key roles are it develops engineers, release managers. The stage 6 diagrams are deployment and maintenance of product, deployment and maintenance or release planning, deployment automation, maintenance finally goes to feedback. Last is maintenance. In this maintenance stage, post deployment support ensures long-term usability. Long-term usability activities are bug fixes, performance tuning, updates, feature enhancements. Outputs are patches, updates and new versions. Key roles, support engineers, developers. Software development lifecycle models. In these models are structured framework that guide the planning, execution and delivery of software projects. They define the sequence of development stages such as requirements design, coding, testing and deployment. Common models are used as waterfall model. In this waterfall model, it is a traditional SDLC model. It follows a linear and sequential approach where one phase is completed before the next phase begins. These are the phases of waterfall model. First is a requirement, next design, development, testing, deployment and maintenance. The advantages of SDLC are it is easy to understand and simple to follow. Follows a clear step-by-step development process. Well-defined stages reduce confusion. Clear milestones make progress tracking easier. Strong documentation throughout the project. Encourages disciplined development practices. Suitable for small project with stable requirements. These are the advantages of software development life cycles. The next heading is embedding security into SDLC. If security is integrated throughout the software development life cycle using a developed scopes approach. It is built into every stage from design to deployment, ensuring continuous protection. The vulnerabilities are identified and fixed early in the development process. Automated security checks are integrated into build and CA or CD pipelines. Security becomes a shared responsibility across development, testing and operations teams. Embedding security into SDLC, it reduces a risk and it improves software resilience and enables the delivery of safer applications. Finally finished. Thank you.